Hello. In this video, we're going to go over the time value of money concept, specifically the present value of different kinds of annuities. First, let's just really quickly recap what is an annuity. And an annuity is a series of cash flows of the same amount received or paid each period. So that's kind of the key feature, is that it is the same amount and it's an installment amounts. And we went over this slide in the previous video where we discussed the future value of annuities. We will still need to know for the present value of annuities, there's the present value of an ordinary annuity, which is when payments occur at the end of each period. And then there's going to be a present value of annuity dues, which is when cash payments occur at the beginning of each period. So let's talk about what is an example of a present value of an ordinary annuity. When we calculate the future value of an ordinary annuity, we know that we have these installment payments, and then we figure out how much we have at the end of the period, whether it's 3 years, 5 years, or whatever. When we're calculating the present value of an annuity, whether it's an ordinary or annuity due, we're working backwards. We're working backwards to figure out how much we need to invest today in order to be able to make certain installments in year 1, 2, 3, etc. So suppose you want to determine the cost today, that tells you that's present value, of a 3-year graduate program. The program's cost is $10,000 each year with payments made at the end of each year. When we see the end of each year, we know it's an ordinary annuity. You use a 10% interest rate. What is the cost of the program? So it's telling us here we need to figure out what's the cost when we have 3 $10,000 payments made at the end of the year. So we know our N, our number of periods, is 3, and it tells us that our interest is 10%. Well, there's 2 ways to calculate this. The first one is to take each one of these $10,000 payments that we pay at some point in the future and figure out how much they're each worth today. So we could take this first $10,000 payment, right, at the end of year 1 and find out the present value of a single sum or of a dollar for the $10,000 for one period. So we could say, okay, our first period is $10,000. Here's our present value of $1, and this tells you which factor table to use, right? So using the right factor table is crucial to getting these answers, these problems correct. And so the present value of this one, $10,000, is $9,091. That tells us if I invest $9,091, and earn 10%, in a year from now, I will have $10,000. So my N equals 1, my number of periods. Then I can calculate my present value of $1 for the second payment of $10,000, and that's going to go over 2 periods, right? This first year and the second year. So here's my 10,000, here's my factor. It's $8,265. That makes sense because if I invest $8,200, let's say $8,265, and I wait and I earn 10% on it for 2 years, I would get $10,000. It makes sense that we need to invest less than and invest it for 2 years than 1 year in order to get the $10,000 amount. Let me just erase that. And then I can calculate the present value of $1 for the $10,000 here over a 3-year period, 1, 2, 3, right? And use a factor N, N equals 3, I equals 10%. Here's my amount, and I get 75.13. And total is 24,869. So it tells me if I invest 24,869 today, and if it earns 10%, I will be able to make a $10,000 payment at the end of year 1, 2, and 3. So just like the future value of an ordinary annuity, we also have the present value of an ordinary annuity factoring tables. And the way we do it is we take our installment payment, which is in our situation $10,000. times some factor, right? And in our situation, it was N equals 3 and I equals 10%. So it gives us here a little snapshot of the table, but I'm just going to go and take you again to the tables like I did in the previous video. And here I still have my tables that, and remember, there's all kinds of tables and it's critical to use the right one. In this situation, we're trying to figure out, let me just, the present value of an ordinary annuity because we're trying to figure out how much money do we need today, so the present value, in order to make a $10,000 payment at the end of each of the next 3 years. So when we make a payment at the end of the period, it's going to be an ordinary annuity. My term is 3 years, so my period, we're going to do it, we're going to do an installment payment 3 times, so 3 periods, so N equals 3, and it tells us that our interest rate is 10%. So here's the 2.48685 is the factor I would use. So let's just go back in here real quick, and here's my 2.48685%. So I take my annuity amount times my factor, gives me my 24,869, which is exactly what I calculated here somewhere. Right here. Here's my 24,869. Okay, now we're going to go over present value of an annuity due. So that means it's going to be installment payments at the beginning of the period. Suppose you wanted to determine the cost today, so we know cost today means present value, of a 3-year graduate program. The program's cost is $10,000 each year with payments made at the beginning of each year. So this is just, the facts are slightly different in that the payments are made at the beginning of the year versus the end of the year. We're still using a 10% rate. So what is the cost of the program? How much would I need to invest today in order to make 3 payments, including a $10,000 payment today, a $10,000 at the end of year 1, and a $10,000 at the end of year 2. Notice we have this end of year 3 here, but nothing happens at the end of year 3. It's irrelevant because we made our first payment on today. So let's see what we could do. We could figure out the present value of each of these payments as a single sum, as a single sum, right? So we would use a present value of $1 table, and we say, okay, what's the present value of $10,000 today? Well, that's just $10,000, right? $10,000 today, you're just going to have $10,000. So we really only need to figure out the present value of these 2 payments at the end of year 1, at the end of year 2, right? So so the second payment right here, this is the second payment. We would only need to figure out what's the present value of this payment for 1 period, right? So my N would equal 1 in this situation. My interest is 10, and here's my factor. So I would take my $10,000 times the present value of a dollar factor, and here's the $9,091 that we had before. And then my third and final installment is made at the end of year 2. And so that in that situation, we're only trying to figure out the present value for 2 periods, 1 and 2. So in that the third installment, we use N equals 2, I equals 10, present value of $1, it's $82.64. So this tells us we would need $27,355 total to invest in order to make a payment of $10,000 right away. So really, we would make the $10,000 today, and then we would have enough money to make a $10,000 payment at the end of year 1 and at the end of year 2. Alternatively, we can also use a factoring table, and this is the present value of an annuity due. AD is for annuity due. And we'll take our payment amount, $10,000, and look at our present value of an annuity due factor table. N equals 3, I equals 10, so we have 3 periods. So again, let's quickly just go back to our tables here. And here's our present value of an ordinary annuity, which is not the case. This, we need the present value of an annuity due of $1. And I'm going to go to N equals 3, and the interest rate is 10. So here is 2.73554. 2.73554, and you take that, multiply by your annuity amount, and you'll get the same number, the 27,355.